In this example, we want to practice verifying solutions. So we're given a function g of x, which is equal to c1 e to the negative 2x plus c2x e to the negative 2x plus 2. And we want to show that this function is solution to the differential equation g double prime of x plus 4g prime of x plus 4g of x is equal to 8. And you assume that c1 and c2 are just arbitrary constants. Actually, they were constants of integration. So let me write g of x is equal to c1 e to the negative 2x plus c2x e to the negative 2x plus 2. All right, now let's find the first derivative. The first derivative is g prime of x. All right, now to take the derivative of this, remember c is a constant, so that's kind of irrelevant. So it'll just be c1 e to the negative 2x times the derivative of the inside part, which is negative 2. Hello, chain rule. And then we have the second piece, which is going to be a little bit trickier because you can see we need product rule as well as chain rule. So we start off by taking the derivative of c2 times x, which is just c2. And we multiply it by e to the negative 2x plus, now we leave c2x alone. We take the derivative of e to the negative 2x, which is e to the negative 2x times negative 2. And then, of course, the derivative of 2 is 0. So this piece involved product rule as well as chain rule, actually, in the back portion. Now I'm going to simplify this. We'll just kind of rewrite it. It's negative 2 e to the negative 2x plus c2 e to the negative 2x. Oh, negative 2c1. Huh. I lost my c1. And then minus 2c2x e to the negative 2x. All right, now I need to take the derivative of this piece. Yes, if you wanted to, put these two together, if you so desired, and kind of pull a factor e to the negative 2x out. But it's not strictly necessary. All right, so that's the first derivative. Now I need the second derivative. Well, again, that would be negative 2c1 e to the negative 2x times negative 2, which will get me 4c1 e to the negative 2x in a second, plus, and then c2 e to the negative 2x times negative 2. And then here I'm going to need product rule again. So I would take the derivative of this piece, which is negative 2c2, and then leave the e to the negative 2x, plus, now I leave the negative 2c2x, and then e to the negative 2x times negative 2. So I'm taking the derivative of the e to the negative 2 part. Well, that's a little bit ugly. So let's do 4c1 e to the negative 2x minus 2c2 e to the negative 2x minus another 2c2 e to the negative 2x plus 4c2 e to the, 4c2x, excuse me, e to the negative 2x. Obviously, these two can be combined together. So that's 4c1 e to the negative 2x minus 4c2 e to the negative 2x plus 4c2x e to the negative 2x. And yes, I could factor an e to the negative 2x out of all of this. Heck, I could take a 4 out as well. So that's a possibility if you want to do that. I'm not going to bother. Maybe I'm doing it wrong, I don't know. But g double prime of x plus 4g prime of x plus 4g of x, 4 times g of x, excuse me, is our equation. And so we want to show that this, I did it wrong again, g of x is equal to 8. That's what we're trying to show. So g double prime is this piece. So I'm going to write 4c1 e to the negative 2x minus 4c2 e to the negative 2x plus 4c2x e to the negative 2x plus 4 times g1. So I'm going to take my g1 that I, or excuse me, g prime that I have, was thinking first derivative. And I'm going to multiply each of these terms by 4. So it's going to be minus 8 c1 e to the negative 2x plus 4 c2 e to the negative 2x. And I'm running out of space here. Minus 8 c2x e to the negative 2x. Right? So I multiplied each of these terms by 4. And then last but not least, the 4g of x piece. So I'm going to take the original function and multiply each term by 4. So plus 4 c1 e to the negative 2x plus 4 c2x e to the negative 2x plus 8. I'm going to add all this up and hope that it equals 8. All right, so let's look for some things that can be combined. So I noticed the 4c1 e to the negative 2x, the minus 8c1 e to the negative 2x, and the 4c1 e to the negative 2x. 4 plus 4, take away 8, is gone. Right, those three all cancel. Then I've got, let's see here, the minus 4c2 e to the negative 2x. That's not a like term because it has that x in it, so I have to skip that one over. Plus 4c2 e to the negative 2x. And that's it. But minus 4 plus 4, those two are gone as well. Right? They make 0. And last but not least, in case you can't see it coming from a mile away, 4c2x, 4c2x, and 8c2x. Maybe if you're colorblind, then maybe it'll help if I do like squigglies so you can kind of see. So these two match those two. And then this bit gone with that bit. And the only thing left is 8. Whew, that was a lot of work. It did in fact work the way that we thought it would. The only thing left was 8. So we verified this solution.